I work at SUSE, and in there I work in the containers team. I'm going to talk a bit about this thing we call openSUSE Kubic, which is an openSUSE distribution. And hopefully by the end of this talk you will know why we did all this and why we went through all this trouble. And also I'm going to talk about SUSE CASP, which is what I'm working on my day-to-day basis. So yeah, let's see. So we started with all this because we realized of certain problems, which probably do not appear as an operating system problems, but it ends up being a problem on the operating system's side as well. First of all, yeah, containers happened. People started to work with microservices. They deployed everywhere, and it was all pretty crazy. And then they realized, yeah, that with Docker alone, you cannot do much because you're stuck with just one machine. Or if you want to go the hacky way, maybe you can go to more machines. But usually you faced lots of problems when it came to deploying containers reliably in your cluster. By cluster, I mean a group of machines. It can range from 10 machines to thousands. So yeah, doing that with Docker alone was really tricky to do. Then we have all this problem with discovering services. So it's like your application is consuming a service, being that like a database or some storage service or whatever, and how these different containers that have been deployed can get access to these different containers that provide such a service. And the other thing was that, yeah, we don't use containers as we are using machines themselves. Rather, we scale up, down pretty easily, and we want to do it without any problems. And then there were all these, I wouldn't say corner cases, but lots of different problems altogether put in, like managing configuration, how to manage secrets, granting access, so on. And so the community came with container orchestrators. Multiple appeared, but I guess that we betted on Kubernetes, which is, of course, a container orchestrator, and it's open source with a big and active community on top of it. And yeah, suddenly people started to bundle everything in microservices once they had this orchestrator in their hands, so they can do all these crazy things reliably. But yeah, what's the operating system in there? So what about the system supporting such microservices? How do we update the operating system? Let's say that we have a kernel update. How that should be handled so it doesn't affect your cluster healthiness? Or yeah, how do you do that in a very reliable manner? So yeah, some considerations before jumping into Kubic itself, like what's our target? So first of all, we have the assumption that application delivery should only be done with containers when we came up with Kubic and CASP. So having a mixed bag of, yeah, have some native apps on my machine and also containers running all together, yeah, that's tricky. We don't want to do that. Only containers, and containerized cluster that want to run at scale. So if Christmas comes in and you want to scale up to 50 more containers of this application, yeah, that should be an option, and the same for scaling down. And I would say the most important, at least for me as a developer, is that a container host should be really easy to set up. When I'm running everything in containers, I don't care about the operating system host. I just want something that just runs containers. And that's one of the goals, like I just want to deploy containers. Don't get me about all these details, how to set up this host machine or stuff like that. And then there's this metaphor that I like, which is pets versus cattle. So you treat a pet with care, you love it, you feed it, and so on. And usually you don't have more than 10 in your home, unless you have a zoo. And yeah, and you really take care of them. But a cattle, as in I have 100 cows, I have 200 cows, and then you put them on a slaughterhouse. Sorry, that's what happens. And you don't have to care about them that much, and you can scale it down, you can scale them down. So yeah, there's this comparison, and in container world, we would be cattle. So servers should be treated as cattle, actually, and the host shouldn't be in the way of it. So, and then there's this other concern, which is upgrading a running system is very dangerous, as in services are running, for example. If my application is accessing a database, yeah, maybe the MySQL service is running, maybe PostgreSQL is running. I don't want to suddenly upgrade MySQL if I don't know if things are going to get messy. Users might be doing things depending on the machine you have. Maybe you have granted access to some users so they perform some operation or something like that. Software changes things, and sometimes on purpose because they have to update some file, or maybe they want to remove some outdated file and so on. And yeah, let's face it, not all packages are packaged properly. And sorry about that, we are a distribution company and so on, but things happen. And this is really tricky when it comes to rolling releases. As in, for openSUSE, we have openSUSE Tumbleweed, but there's also Arch Linux and so on. And when that happens is that it can get pretty tricky when it comes to intrusive updates, as in, like big names, sys5 to systemd, what should we do there? Or when I measure versions for complex stacks, like, I don't know, KDE or something like that. The updates are really tricky in general. So one thing we came up with is transactional updates is not something it was born in SUSE or something like that. Other people were doing it before us. But yeah, we came up with this tool called, cleverly named Transactional Update. It's open source. You can find it in the openSUSE GitHub organization. And the ideal goal of transactional updates is that we want updates that are atomic and that can be rolled back. This transactional update implements transactional updates for openSUSE or SUSE Linux Enterprise. It uses Btrfs because by that feature of can be rolled back, we need it for snapshotting and rollback. So the main idea of it, I'm going to gloss over lots of details, but the main idea is that whenever you want to do an update, you create a Btrfs snapshot, then you jump on it after rebooting, and then it kind of makes this question, does it work? If it does, yeah, this is the new root file system. If it doesn't, let's roll back to our previous state. So with that, you have an update mechanism in which updates can be rolled back, and it's atomic. As in, if you want to update multiple things at once, you can. And it will be done in one operation, and one restart will have the new updated software. Then, so yeah, you have this software called transactional updates. Now we want an operating system that takes care of such a thing. And what we came up was MicroOS. So MicroOS is maybe a similar idea to something you've already seen in other places, like CoreOS. It's a similar idea, so you have a very minimalistic operating system that is specifically tailored to containers and Kubernetes. Btrfs is the file system, of course. Otherwise, we wouldn't have these automatic and transactional updates. And then we decided that it would be read-only for the most part. There are certain paths like etc and such things that can be written, but for the most part are read-only. And then you can have a dashboard for bootstrapping and managing your cluster. By that we mean that at your desk you would have this web application in which you would say, I want to have these machines to be part of my cluster. Let it be a Kubernetes cluster. That would be the main idea of such a dashboard. We initially started this project called Vellum. And yeah, we're transitioning to kubeadmin, which is a tool which is being built by the community. When we started Vellum, kubeadmin wasn't a thing, it didn't exist, so we had to come up with our own thing. But yeah, in the future we are moving towards kubeadmin, which makes more sense, as in we don't want to reinvent the wheel. We don't. Yeah. And I came here to talk about Kubic though. And what is Kubic? I haven't said anything about Kubic. So it's a sub-project of the openSUSE project. It's an openSUSE distribution. It was founded in May 2017. It's completely open source. You can see different repos on GitHub at Kubic-project. We also build the packages on OBS in the open, so you can actually install it with zipper and so on. And again, it's a distribution which is using macOS, and you can install different dashboards to administrate it, like Vellum or kubeadmin. And what is CASP? So that is the thing I'm working on. It was founded around the same time. It's been worked on in parallel to openSUSE Kubic, and you can imagine it as like the customer-oriented Kubic. I'm really not saying it right, but you can think of it kind of like that. So it's built upon the feedback we got from customers, and from that we are gearing towards one route or the other. Kubic is more focused on what the community needs or might need in the future. And right now, in version 3, SUSE CASP is using macOS and Kubic as the upstream distribution. This might change in the future. For example, for the next version for CASP, we had these customers that said, okay, this macOS idea is cool and so on, but we are already happy with SUSE Linux Enterprise. We don't want to, nuke my machines and put this operating system we don't know. And so in the future, we will also support other distributions like SUSE Linux Enterprise. And also for the future, we want to get closer to Kubernetes upstream. This is not the same as following the Kubernetes version only, rather also all the toolings, all the mechanisms, and so on that the Kubernetes community is coming up with. And yeah, so we want to have more integration when it comes to technologies that are being polished and refined by the community. We don't want to reinvent the wheel. And as I said, we want to support more operating systems, at least in SUSE CASP, because as I said, it might be too disruptive for some of our customers which are happy enough with Sleep. And yeah, as always, we will keep polishing and keep squashing bugs, because yeah, new products have bugs and so on, so it's an endless loop of polishing and so on. And that is all for my talk, actually, pretty small. Do you have a question? Yeah.
So this macOS thing, it is Linux without being Linux. It's a Linux kernel, just compiled differently, or not, or it's a different thing.
So it's, you can think of it as a distribution like openSUSE and so on, but it's only like the kernel, and all we need to run Kubernetes. All the packages we need to run Kubernetes. And with the transactional updates tool and so on. No more questions? Okay, then that's all for me.